Is it already open? Hey, Chris. Apparently. It's just about time to start, so if people could find seats, please. Welcome.
See you again. I invited Tim. I didn't know he was at the president's office.
Yeah, he's at the White House. Office of Technology, OST. Office of Technology Policy.
Very sure. I saw him like wandering away in the distance.
Yeah. National Security and International Affairs.
It's quite a
I
title.
wonder how that got together. Deer in the headlights and shot number one.
So that includes Andrew's slides, right?
Yes.
Okay. Just checking.
And I didn't check this one. The previous version did this was just swapping something out for Jane, so hopefully we're good to go now.
All right, it's time. What? No, I'm fine. Okay, could you find your seats, please? It's time to get started. Tonight we're going to start the meeting with three reports. Report from the IAB, report from the IRTF Chair, and report from the RSC, and a report from the RFC Series Editor. So after that report, we'll have a technical topic. And then after that, we will have the open microphone time for the IB. So I want to go over a few highlights for things that have happened since we were last together in London. The IB sent some comments to the National Institute of Standards and Technology, encouraging transparency and openness in all of their publications. This was in response to an announcement that they were going to be more open and transparent in developing the federal information processing standards, but we thought it should apply to all of their security-related documents. The IB also commented to ICANN on the principles and mechanisms and processes that ought to be used in the development of a proposal to NTIA on the transition of the IANA function stewardship. We appointed Sarah Banks and Robert Sparks to the RFC Series Oversight Committee. We appointed Sean Turner to the Internet Society Board of Trustees, and RC 288 on reflections on host firewalls was published. And then we appointed Matt Miller as the liaison manager for ECMA TC39. We also got a workshop report on congestion control published as RFC 7295. We got a workshop report on the Internet Technology Adoption and Transition published as RFC 3705. And we appointed myself and Lindsay Namor to the coordination group on the transition of the IANA stewardship. And lastly, we published a document describing the IEEE 802 and the IETF relationship as RFC 7241. That's actually an update to RFC 4441, or a replacement for. So this slide shows all of the documents that are currently being worked on by the IAB. I'm not going to go down each one, other than say two of them, the one at the top and the one at the bottom, actually are intended to be BCPs, so the ISG will handle the last call and so on for those documents. In terms of the standards process, we did not receive any appeals since London. Ongoing appointments. We are trying to fill a seat on the 2015 ICANN nominating committee. We had asked for volunteers by last Friday, and we have extended that till this Friday in the hopes that we can get a few more nominees or volunteers to become members of that nominating committee. So please contact us immediately if you're interested in that position. Right now we have 2 people who have volunteered. We'd just like a bigger pool to choose from. And the independent stream editor, the IAB is seeking feedback on the job that Neville is doing. Basically, the feedback will determine what, if any, other actions are needed. Because basically the contract with Neville is about to expire, and we have a choice of putting a contract with someone else or renewing that contract. So a couple highlights from the IAB retreat. We met in conjunction with LACNIC in Cancun, Mexico. They had a meeting there, and so we joined them. And one of the big things we did is restructured the IAB programs to allow the IAB to focus on the topics that are most relevant to the internet today. There's a whole bunch of backup slides to this presentation. If you want to download those from the proceedings page, there's a slide at the back about each of the programs and what we're going to focus on this year. One highlight is that we previously had a privacy program and a security program. They have been merged to the privacy and security program, and it is going to be a focus of significant effort in 2014 for the IAB. These are the current list of programs, and the URL at the top, you can learn about those. I don't intend to go through them. As I said, the backup slides about each one of those are there. And that's the end of my report. Lars, you're next.
Hello. Well, it's loud now. I'm Lars Eggert. I chair the IRTF. This is the short version of the report. As usual, the long version of the report happens at the IRTF open meeting, which I think is Wednesday or Tuesday. It'll be in the slides. So we have 4 research groups that are meeting this week. That's a little bit fewer than normally. And we have 2 proposed research groups that are meeting. The ones that are meeting are the Information Centric Networking Research Group, Crypto Forum, Software-Defined Networking, and Network Management. There's a proposed research group on data center latency control. They had a side meeting in London. They have an on the agenda meeting now on Friday, I think morning. And then there is a proposed new research group on network function virtualization, and they have an off-the-agenda side meeting, I think, during Wednesday lunch. And there's a DCLC and an NVFRG mailing list at IRTF.org that you can join if you're interested in those. The IRTF open meeting, as I mentioned earlier, it is on Tuesday at 14:20. Unlike other IETF meetings, we are not reviewing the progress of one research group with the IAB this time, the reason being that fewer meeting and so few chairs are here, and there also wasn't any pressing need because we reviewed most of them in the last year or two. So we decided to spend that time with the IAB on something else. There's a third proposed research group that exists called Gaia, which stands for Global Access to the Internet for All. They aren't meeting here, but they have a meeting in Cambridge in October, I think, and they have a meeting co-located with the ACM Dev conference in San Francisco in December. And the mailing list is Gaia at IRTF.org, and if you're interested in that, join that list. It's my personal take of the research group's activity levels at the moment. You know, 3 out of the 4 seem to be active at the moment. 3 out of 7 seem to be active. 4 out of 7, maybe not so much, but that's not uncommon. Research groups go dormant for a number of reasons. And we closed 2 since London. We closed the network complexity research group that had run a little bit out of steam, and we closed the routing research group because that had run out of steam also. That doesn't mean that we will never do any routing research again in the IRTF. It just means that now there's a clean playing field for somebody to, you know, come up with a group with a maybe new focus or a new emphasis in routing and pitch it. I believe it's better to close things and let, you know, a new group start rather than trying to keep something alive past its prime. This is our stream. It's not very busy. We had 3 RFCs published since London, which is quite good for us. 2 of them are from the DT Energy and 1 is from the Crypto Forum Research Group. The DT Energy has published some bundle protocol related RFCs, and Crypto Forum published the OCP encryption algorithm. Finally, we are giving out the Applied Networking Research Prize. By now, everybody probably seen this slide many times. This is together with ISOC, who graciously is funding this. For 2014, we had 46 nominations of research papers that, you know, attempted to get selected for the prize. We have a selection committee that consists of a bunch of IETF people, some IRTF folks, some professors, some of the past prize winners we have invited. We picked 6 winners for 2014. 2 of them have already presented in London. 2 more were supposed to present here. One of them, Misbah, had trouble getting a visa to Canada, so he will present in Honolulu together with the other 2 winners for 2014. And Robert Leitchev will be presenting his research on the partial deployment of secure BGP during the IRTF open meeting on Tuesday. We did actually add another talk to the IRTF open meeting because Misbah couldn't come and we had the slot. So we moved a talk on what you need to do in terms of having stable or reliable crypto in the age of quantum computing that was scheduled for the CFRG. We moved that because it's probably of broader interest to the IRTF open meeting. So if that is of interest to you, you have a second reason to come to the IRTF open meeting. The nomination period for the 2015 award cycle is open now. I think it'll close sometime in October. So if you read papers, if you come across a research paper that you see published or that maybe you published yourself recently that you think is eligible for the award because it's applied and it's relevant to us, please nominate yourself or please nominate, you know, the author of that paper. We try to pick good papers, but we can only pick papers that have been actually nominated. So if you want to see good talks, help us find them. Thank you.
That's not good.
Hello, everybody. I'm Heather Flanagan, RFC Series Editor, and I want to take a moment to congratulate you all on an incredibly productive year. You've sent us a lot of documents. this has been an unusually high surge of documents. At this point, we've already seen 70% of what we had last year in our system at this point in time. It's been pretty impressive. We were talking anecdotally, and we can't remember seeing a bigger spike in the history of this series. This means that the RPC, the RFC Production Center, has not met their SLA, which is getting 67% of documents that are in an RFC editor-controlled state published in 6 weeks or less. Probably the biggest factor to all of that, it wasn't just a question of a whole lot of documents, it's that several of those documents were sent in clusters, and clusters are always a little more challenging to work with because there's a lot more cross-references and terminologies that has to be checked. Some of these clusters might be familiar to you. I suspect some of you have worked on one or more of them. Storm started our year with only 5 documents, but those 5 documents resulted in 574 pages. The average RFC is about 30 pages, give or take. So that was kind of the equivalent of 19 documents in a cluster all hitting us at the same time. Also this year, HTTP-Biz, Manet, and Trill. Some of them had very, an average number of pages per document, but perhaps some more extended Auth48 sessions than we might usually see. All of these clusters, by the way, are published at this point. But they were definitely a pretty big impact in the RPC's ability to actually get documents published in 6 weeks or less. I have some graphs to help those who are more visually oriented see what kind of happened over the course of this year and to be able to compare it to last year as well. These are also to be found in the RFC editor report that gets included, links are included to that in the Ops and Admin Review plenary on Wednesday. One of the things I want you to take away from this is, you see that really big column? Good job. But it's going down from there. It's trending in the right direction, so we're not concerned. But we wanted to make sure the community was aware that this was happening. So, summarizing the SLA, the feedback on the mic is killing me. That's our chart that keeps track, a rolling track of the last 12 months and where things stand. Beyond that, we get into some of my hot and heavy projects, including RFC format. I think some of you may have heard that I'm working on RFC format and changing the canonical format from text to the XML will be the canonical format, and from there, publication formats will be rendered, HTML, PDF, text, and EPUB if we can get someone to help us get the requirements in. We'll do EPUB eventually, I just don't know if it will roll out at the same time. It's been very busy since our last meeting in London, and there's many drafts to look at. The tools development team is working on the statements of work that will help get these tools ready for when we actually roll the format out. And if you want more gory details, and a chance to talk a little bit about the style sheet prototypes for what the HTML will look like, you'll want to be at the format session Tuesday after lunch. One of the projects I'd been working on fairly heavily since I started was the style guide, and I'm happy to say that's an Auth48 right now, RFC to be 7322. Some of the significant changes. I think probably the most popular change I heard from the community was the fact that the internet drafts string will be included in the reference format. A lot of people really like that, which is good because it makes sense. There's going to be a web component of the style guide so that we have a section where we can develop guidance when new things come up or adapt things that change a little bit more quickly than we would want to publish a new RFC. And you can see some of the other highlights there. That should be published before before too much longer. I'm waiting on my co-author. He's here somewhere. Okay, digital object identifiers. This is also something that's been very popular in the community. We are working on that. As folks know, the IAB approved starting the assignment of DOIs to RFCs. This will be to all published RFCs, past, present, and future. It's not talking about internet drafts, just talking about RFCs. And the tools development team and I are wrapping up the draft for the statement of work for the project, and you guys can expect to see that going out for community comment real soon now. For the internet draft that's describing DOIs, we're leaving that in draft form right now because we'd like to get some real-world experience and then update the draft to match reality, and wouldn't that be a lovely thing? So there's several ways to find out what I'm doing or to discuss some of the big pictures on format or suggestions on style or anything else you might want. There's, of course, my wiki, which I use as my own brain dump regarding what I'm working on, and I sort of update it in searches as I can. There's the RSE interest mailing list. How many of you are subscribed to that? Cool. Gosh, you like clumped together. How did you know? Cool. And of course, you're more than welcome to contact the RFC Series Oversight Committee to talk about any concerns you might have with the direction of the series or what I'm doing or anything along those lines. And that's what I have for you. Thank you very much. David.
David Black. Storm Working Group chairs, the responsible or perhaps guilty chair for that large cluster. That cluster, by the way, is the new version of iSCSI specs, which is a major accomplishment for the IETF. They're in widespread use and a credit to what we get done around here. I wanted to thank you and commend the RFC editor organization for what was done on those drafts. You left out the rest of the story, which is that we had to ask you to put a bit of a rush on publication of those drafts for coordination with another standards body. The RSC editor set a processing schedule, kept to it. No end of impressed with the professionalism, attention to detail, and patience of the folks doing it. This is one more example of why the RFC editor contributes to the high quality of the IETF's standards. Thank you very much, and thank you to all your organization.
Thank you very much. Thank you on behalf of the editors who did so much of that work and continue to do so much of that work. So thanks all very much.
Andrew, would you and your panel come on up?
Thank you. I'm Andrew Sullivan, and I'm your moderator today for a discussion about internet topology and geography. Some while ago, Michael Richardson suggested to the IAB that we have a look at the IXmaps project website. He noticed a grant, I guess, that the Canadian Internet Registration Authority had given them, CIRA. And CIRA is the registry for .ca here in Canada. And of course, we like to invite people who are part of the local networking community when we have these topics. So we were excited to begin with to talk to the IXmaps people, but also this led us naturally to think about some things that have been forced upon us anyway. So it was a happy coincidence. There are, of course, people and governments who are keen to link intranetwork traffic to geography, to geopolitical boundaries, and so on. But there are also real issues of geography that affect the way the network operates, and this is perhaps clearer than it would be in other places because, of course, Canada is huge, but like practically nobody in it. So you end up with this funny geography and the network topology that goes with it. So today we have three speakers to talk about aspects of network topology and the way it interacts with geography. First, we'll have Antonio Gamba. He's a PhD student at the Faculty of Information Information at the University of Toronto. He studies how the uses of do-it-yourself microelectronics constitute innovative forms for literacy as they entail new forms for collecting, interpreting, sharing, and negotiating information. But he's also a member of the aforementioned IXmaps project at U of T. He works with Professor Andrew Clement, who's there as well. And by the way, he is participating remotely because he's in BC right now. Jane Coffin is the Director of Development Strategy at the Internet Society. She coordinates collaborative strategies for expanding Internet infrastructure, access and related capacities, particularly among emerging economies. And this includes ISOC's efforts to promote Internet exchanges. Finally, Amal Gamba-Bari is a research scientist at the Center for Applied Internet Data Analysis. I always get this one wrong, that's CADA. He does research in Internet measurement, Internet topology, and Internet economics. Each of them will give a short little presentation and then about some aspects of their work, and then we're going to have an open discussion. So I'm looking forward to the discussion. We already had a little mini discussion with them among the IAB. It was very productive, so I'm looking forward to this. So without further ado, Antonio first. Oh, I'm sorry. Here we are. Oh, you should be there, right?
Yeah. Good afternoon, everyone. Yes, thank you, Andrew, for this introduction. I'm Antonio Gamba-Bari. I'm part of the team of researchers at the University of Toronto. Thank you. As Andrew said, we are students at the University of Toronto. Our professor, Andrew Clement, is here and listening to us. So we are grateful at the iLab for the opportunity to present our work to you in the company of ISOC and CADA on the topic of network topology and geography. Since 2009, we have been developing the IXmaps Internet Mapping tool, designed mainly to help individuals understand where their internet traffic is routed and whether the National Security Agency may be intercepting their communication in their road. We hope our work will raise personal privacy awareness as well as inform public policy debates about internet surveillance and routing. We encourage people from disparate geographic locations and ISPs to install and run our traceroute program to feed our database with traceroute. Through host name parsing, latency comparison, and topological analysis, we geolocate the intermediate routers for mapping the routes their packets take. We highlight the exchange points where these routes pass through suspected sites of NSA interception. As part of our public education mission, we have produced several videos to better visualize internet structure and routing. Together with its together with its personal and policy implication. So I'm going to show one of these videos that we have created, and so if you allowed me.
That by developing a trace route generation program so that people can anonymously contribute their own routes to our database. We've also been reaching out to the general public by presenting our findings in lectures and informational events at the Ontario Science Centre, and by developing our Explore page, where users can check out geographical representations of the data we've collected.
Well, I hope we're dispelling some of the myths that get in the way of that effective understanding. In particular, the idea that the internet is a cloud, as an ethereal space that doesn't have any borders. In fact, the internet consists centrally of a few very important points, internet exchange points, and other switching centers. These are in big buildings at the center of cities, and who owns those and the deals that are made there are basically what drives the internet routing.
Did you know that a lot of internet traffic that begins in Canada and ends in Canada travels via the US? We call this boomerang routing.
For instance, if I send an email to Nancy and she's at OCAD, which you can see right there, it basically goes down the street to the McClellan Physics Lab, and then the packets go from there to OCAD pretty directly. if I send an email to Ontario Student Assistance Program, which is just over there, it goes, from here to New York, Chicago, and then back here. And I think that that sort of contrast is really a striking one and helps drive home the point about the physical aspects, but also the peculiarities of routing. We tend to assume that the internet is structured as a very efficient way of routing packets, but how the internet is actually put together is through a series of private arrangements, largely, between carriers. And for various reasons, they're very selective about who they exchange their traffic with. And that's why there's such a difference between the two routes from here to OCAD and to OSAP. It's because of the carriers that are involved. It's not about efficiency of routing.
One of the big problems with cyber surveillance, this tracking of our activity through the networks, is that it's done invisibly. And it can be done on a mass basis all simultaneously.
Right now in the USA, the National Security Agency is conducting a comprehensive domestic surveillance operation. Since 9/11, in conjunction with the USA Patriot Act, the NSA has the power to surveil, without a warrant, the communications of US citizens and anyone else using US networks. One such operation at the AT&T building at 611 Folsom Street in San Francisco was exposed by the whistleblower Mark Klein, a former AT&T technician. He has provided documents showing that AT&T allowed the NSA to install splitters in its main communications links. These devices physically split the fiber optic cable to produce two identical data streams. One stream proceeds as usual, but its copy is fed into extremely powerful NARIS computers that are programmed to intercept particular types of traffic. Additionally, data intercepted by splitters is stored for later analysis. Currently, the NSA is building a huge data storage facility in Bluffdale, Utah. With this facility, experts estimate that the NSA will have the ability to store a copy of the internet and phone transactions of every American for decades to come. Remember that almost all US internet traffic passes through these 18 cities. This means that the NSA can achieve extremely far-reaching and comprehensive surveillance of internet activities by setting up their infrastructure in relatively few intercept points. And because of the convoluted politics of routing, this is not only a concern for Americans. Canadians too are subject to this surveillance, as much as Canadian internet traffic passes through the USA.
Okay, so our work has shown that NSA interception in just 18 US cities can capture nearly 100% of US domestic traffic. Foreign traffic that transits the US is also very likely to be intercepted. From our data, we estimate that 25% of domestic Canadian traffic is routed via the US and hence subject to NSA surveillance. Recent work has focused on the comparative data of privacy transparency of carriers and ISPs. We have shown that, contrary to Canadian and European privacy law, they generally do very poor job informing customers of how their internet communication is handled and whether they protect them from state surveillance. Encouraged by the response we have received so far, we are keen to transform IXmaps from a research prototype into a more widely usable internet mapping and policy analysis tool. With funding from the Canadian Internet Registration Authority, we will be rebuilding our traceroute generation application to make it more reliable and flexible in the face of the challenges and changes in routing practices, as well as make it easier for individuals to initiate their own traceroute generation. We also need to automate and improve the accuracy of our geolocation process, in part through crowdsourcing, and improve the accuracy of technical backgrounds in these areas, which we are currently doing so. We don't have a strong technological background in these areas, and so we are currently looking for experienced developers to work in our traceroute generation and geolocation, geolocation modules. Our call for, so far we have focused on North American routing, while our techniques are applicable elsewhere. We don't have the resources to respond adequately to the interest we have received in other countries. We welcome offers of help internationalizing IXmaps and making it more sustainable. In particular, we will put shortly, we will put it under the free open source software license to make it easier for others to take it on their own directions. And quickly, I'm wanting to point to our website. If there are any details that you want us to, we are welcome to answer them. By the end of the month, we will be releasing this call for proposals for recruiting developers and other network analysts that could help us to push this project further. So thank you so much for your attention.
Great. Good evening, and thank you very much. My name is Jane Coffin. I work for the Internet Society. Although I'm standing up here by myself, think of about 15 to 50 other people who do work with us. We do work in partnership both inside the Internet Society with colleagues around the world in different regions, but also with organizations like the Regional Internet Registries, EuroIX, other IX associations around the world like AFIX, APIX, LACIX, and others. This is to develop internet infrastructure, and again, I would agree, the cloud is not something we're working on. We're working on hardcore infrastructure, building local infrastructure. So I have colleagues here in the room with us. If you have any questions, if you speak Spanish, Christian O'Flaherty is here, and we have other ways that we can talk about what we're doing with other partners. What is an internet exchange point? Many of you do know. It's a physical location where different IP networks meet to exchange traffic, often, and keep local traffic local. This is important to the Snowden debate later, and I'll come back to that at the end. Often people will say, oh, Jane, they're just boxes and wires. Well, we know from past experience and experience with our partners that 80% of the engineering in an IX is human. 20 is generally the technical. Philip Smith and I were in Papua New Guinea about 3 weeks ago, and he said, nope, it's 95-5. 95% of this is the human engineering, how we bring the different character sets together of ISPs, network operators, research and education networks. They're a vital part of the internet ecosystem. It is not a magic bullet. It is not the one and only thing, but it's critical to develop the human, the technical, and the governance infrastructures in countries. Again, keeping local traffic local is one of the aspects. You build local internet communities of interest that may not have existed or strengthen those that were latent or just in development. You improve the quality of internet services. You drive up demand, latency comes down, quality of service usually goes up. I'll try not to talk so fast. It's a convenient hub also for attracting hosting infrastructure. Content is key, as many of you know. Content is generated by businesses that have confidence in those infrastructures. And we know this is a catalyst for overall internet development from our experience, what we've seen. We've put out reports to help document the impact of IXPs. My colleague Karen Rose was instrumental to this study, as was Muchuki Mwangi in Kenya, and some of the IX types in Nigeria. The important thing here that we were able to prove, particularly in Kenya, from 200 to 600 milliseconds, those of you that know how important this is, reduced to 2 to 10 milliseconds. In Nigeria, from 200 to 400 milliseconds to 2 to 10 milliseconds. There were direct savings for some of the mobile operators on international transit. This was important, particularly in developing economies. These IXs also help facilitate e-government services. In Kenya, the tax authorities peer at the IX. It was critical for the local infrastructure. for them to peer at the local infrastructure. They also catalyze local hosting and content, as I said, increased the mobile data market, and attracted regional traffic, particularly to KXP. So there are international networks coming into peer. So it comes from the national to the regional, and now we're attracting international peers. We've also put together a study, again, some data for you to prove that in Latin America, some of the findings we've seen, working with a professor at the University of San Andres, in Argentina, in one city alone, after the IX was installed, they went from $100 per megabit per second down to 40. This is huge. Recently, when I met one of the key people, Antonio Harris at Cabase, which is the network in Argentina, 11 IXPs, he told me just the threat of Cabase coming into a city recently brought down the price per megabit per second from about 250 to about 10 or 20. It's really interesting to see what happens in these environments where there was some competition and it's growing, particularly when the IX has come in. In Brazil at NIC.BR and the PTT metro system, sorry, there's a typo there, there are 26 IXPs, and we recently chatted with them today. They're up to 600 gigabits per second at peak. That's huge. They've created an amazing system working with the government and companies across the country. In Ecuador, before the IXP went in, international transit was $100 per megabit per second. It's now local traffic cost, local is $1 per megabit per second. They're also running RPKI. You'll hear more about that tomorrow, I think at the OPSEC meeting. It's at 1300. Give it a go to have a look, because it's interesting to talk to the people that are deploying new technologies through the IXPs. IXs also can be a place to host your CCTLD, put in a time server, and deploy IPv6 as well. After the CDN cache was installed in Quito in 2009, traffic went up by 700%. This is local traffic. Additional work that we're doing in the region, and again, this is inside the region with people that speak the language and know the regional actors. We're putting in 12 Raspberry Pis in Bolivia to take a look pre-IXP and then to take a look during the IXP traffic deployment, and how with the service and the quality of service goes up or down. We'll take a look there. Network efficiency, studied in Argentina with a professor at the University of Buenos Aires, again to take a look at Cabase's network to see how network efficiencies can be improved and what we can do to help them there. The study can be found at the link in the text here. There are over about 350 IXPs around the world. There are different mapping technologies being used to take a look at that. This is a telegeography map. There are also maps on our website at the ixptoolkit.org. There's one at euroix.net, and Packet Clearinghouse also has mapping. When we take a look at building capacity in different countries, we often will, of course, consult with the local community, work with other local actors, try and take a look at how we can make the IXP grow if it exists, how it can be a part of that ecosystem, and what the right business models are. Usually it's leveling up over time from a startup to an entity that might be charging for some of its services. We often help with equipment as well, because the startups are difficult. With technical skills, we're taking a look at helping them with routing, network management, and network efficiencies, running the IX and working with the local internet community and different authorities. In a lot of countries, you do need to work with the government. That may be antithetical for some, but it's very important to figure out what the enabling environment can be for the government, working with the technical community that you're building. In Africa, we have two projects called the Axis 1 and 2. This is with the African Union. The Axis 1 project was something we bid on and won due to the great guys that we work with in the region. Machuki Mwangi, Kevin Chegi, Dawit Bekele are part of that team. There were 30 best practices workshops, bringing the community of interest together to kind of coalesce. It's not easy. And then 30 technical aspects workshops. These are a bit more hardcore. This is BGP, how to run it, engineer it, how to interface with the IX, and also whether or not you're running V6 and other relevant services. There have been 4 IXPs launched this year, and this is quite something because it started in 2012. In 2014, we've been working with Afrinic, Jaguar Networks out of France, Lyon IX, and INEX, which is the Internet Neutral Exchange in Dublin. Axis 2, 5 regional meetings across Africa to bring regulators, policymakers, network types together to explain the importance of growing that regional infrastructure. There are so many landlocked countries in Africa that it's important for some of those government entities to try and work together. There was one instance in Zimbabwe where it took almost 2 months to string some fiber about 100 meters due to the fact that it was over a bridge that was historic. There were different authorities, from the customs officials to the border officials to the communications ministry, and they've often come to us and others and said, can you do something? Talk to some of these officials, see if you can help us facilitate a discussion, because how is it that it takes, from a business perspective, over a month to deploy that fiber? It's not good for the business, it's not good for the community, it's not good for deploying that infrastructure. We also host something called the AFPIF in Africa, the African Peering and Interconnection Forum. The next one, the 5th, which is quite something, it's kind of a benchmark for us, will be at the end of August. This brings peering coordinators together, network managers together. It's a really interesting event where IXPs that are starting out can talk to more robust IXPs. They also have a chance to interface with each other, have meetups with some of the network operators in the region as well. Latin America, countries knew that we knew that looking at certain countries that had deployed IXPs, that certain factors existed from the market conditions and the regulatory and policy environments. Those are Argentina and Brazil. That's over 16 years of IX deployment. Countries that we're working with now who have recently deployed IXPs had some of those conditions that weren't as strong. Not a very strong internet community. Some of the market conditions, again, from the policy and regulatory side were down. It's why we work so closely with governments. We provide some pre-best practices training where we invite companies in through the government. Sometimes it's the only way to get them to the table. We have a joint training objective, which is also training the government to appreciate that the technical community should run the infrastructure. The government can help enable. We've seen some interesting cases in Costa Rica and Bolivia, where in Costa Rica the government was less restrictive and the environment has progressed faster for developing the IXP, and I believe they just launched it. In Bolivia, it's taken us a bit longer. The IX is now embedded in a law. It must be licensed. Anything related to interconnection is also being heavily regulated. So we work as much as we can, slowly, it's step by step, with the government, with the community, and we try and build up that internet community as we're going so it can do what it can with the government. It's not an easy process. Again, some of the training we do in the region, introduction to BGP and traffic engineering. We do a lot of joint training, and I want to stress the partnerships here. LACNIC, LACNOG, PCH, governments, company experts, the basics of architecture, and how to obtain resources. You'd be surprised at how many operators don't have ASNs and may not know where to get some of those addresses. They're working through their upstreams. So often we'll go into Africa and other Latin American countries. They'll still talk to LACNIC or AFRINIC about obtaining those resources, but it still happens that some people don't have ASNs in their infrastructure, or they're not, don't have the right addressing plans as well. With respect to equipment, I mentioned earlier, the startup phase is often one of the most difficult. We help donate new equipment to IXPs to help them get started and help install that equipment and explain to them how to keep it going. We do help level up existing IXPs, which means that if they need a new switch, router, server, they can come to us and we often can help them with that donation. Partnerships that have been developed in that region. Development of LAC-IX was through the Internet Society and LACNIC. ISOC's been working with LACNIC to train partners in the region. That RPKI deployment was one of the key things in Ecuador, and that was thanks to LACNIC. Community building, Regional Interconnection Forum. This is within the LACNIC meetings. There is a LAC Peering Forum. This is a working group within LACNOG. I didn't stress earlier, but the network operator groups are critical to that infrastructure development and internet technical capacity training for people in the region. Some of our other partners there, again, LACNIC, LAC-IX, NIC-VR, Packet Clearinghouse, LAC-TLD. Working with governments critical, companies and organizations like Cisco and the Google Foundation. I'd be remiss if I didn't mention them as they provide grants and equipment to us. We also have an IXP Toolkit and Best Practices Project grant. This is more of a global project to look at places where there isn't as much of a robust infrastructure, or we can help facilitate other partnerships. The grant builds on our previous efforts, and it's creating an IXP Toolkit report. It's a study and a methodology to identify best practices, creating and improving an IXP portal, fancy name for a website, partnering to conduct training and hold workshops, building capacity around the world, and that's working with academics, the IX associations, other IXPs who have great experience around the world, and the RIRs, and NSRC in the works in Asia Pacific. We've worked across Eastern Europe, recently in Papua New Guinea. Samoa is interested. We don't often have to be the end entity that's in place in the region to help out, we can often hand off. So we're not ever trying to be the one and only, but bring partners together. As I said before, Philip Smith was with us. Many of you know him. He's got amazing experience, and NSRC is very interested in making sure they can maximize some of the work in the region. The last thing I'll note, in the toolkit, we're using open source software for our mapping technology. It's a little wonky at times, but it's kind of cool when you look at this because there are a lot of different IXs that want to see themselves on the maps. So it's something of interest to them. It was one of the first, we got about 25 hits at the Apricot meeting in Malaysia in February where we rolled out the toolkit. Now, Snowden-related aspects of this, keeping local traffic local is a critical part of that IX infrastructure. If you are tromboning your traffic or boomeranging it, if you're sending your traffic from Nairobi to London to exchange between two ISPs in Nairobi, that's not efficient, right? Time and distance equals money, a lot of other aspects there. But if you're exchanging traffic locally with each other, you're driving down cost, you're increasing your quality of service, and you're driving down the latency. This is a critical thing. We do get questions from local governments now about the Snowden impact on IXPs. What is the IX set up to do? Well, obviously it's to peer and switch exchange traffic. It is not set up to be a monitoring facility for deep packet inspection, or at least that's our philosophy. Could someone do that? Yes. But do we come in with that? No. Just wanted to be clear, this is a question we get very frequently now, more often. Again, we're trying to keep local traffic local for network resiliency reasons, for development of that internet infrastructure, for local human capacity development as well, and for content creation and design, because that's going to develop that infrastructure more as you go forward. In any event, I'll leave you with all that, but this is part of what we're doing around the world with partners. And again, thank you very much for your time.
Good evening. My name is Amok Damdere. I'm a researcher at CADA, and today I'm going to be talking about some of the tools and the data sets and research that we're making available to the community to support sort of the general theme of topology and geography research and analysis. So CADA, we're the Center for Applied Internet Data Analysis, recent name change actually, but we kept the same letters. We're a research group at the University of California, San Diego. We're at the Supercomputer Center. We do look at both practical and theoretical aspects of the internet. We do a lot of network measurements and data collection and data sharing. So jumping quickly right into the theme of today, which is topology and geography. We have built and operate an active measurement infrastructure, which is called Archipelago or ARC. And as of today, it consists of 102 monitors, and it grows pretty consistently at about 1 or 2 a month. 37 of these monitors are IPv6 capable. 39 countries and 88 cities are represented. And 54 of these monitors are actually little Raspberry Pi computers. And those are pretty much what we hand out these days as our monitors. Lots of different projects run on this infrastructure. We have ongoing team probing experiments to collect IPv4 and IPv6 topology by doing large numbers of trace routes to pretty much the entire routed v4 and v6 space. We do alias resolution measurements to collect router level topologies. Recently, we've started using these monitors to do some measurements of interdomain congestion to figure out where congestion is on peering points between networks. And various other researcher measurements, such as spoofing measurements, also run on these monitors. So as I said, just on the last slide, the monitors that we hand out these days are pretty much these Raspberry Pi computers. We all know what these are. They're not super high-powered devices, but they're good enough to do the job that we want from them, which is basic network measurements. The good thing is they only cost $35 a piece, and it's pretty easy to hand them out to people and get them to host them. So we're always looking for new vantage points, and if you can, if you're willing to host one of these either at your organization or at your home, we would be most happy to have another vantage point. So the Archipelago infrastructure has actually been operational since 2007 when the IPv4 topology probing started, and IPv6 started a year later in 2008. It's generated a huge amount of data, coming on to 6 terabytes of compressed data at this point. This consists of both IPv4 and IPv6. You can see here on this picture the number of monitors that we've had over the years, and it's steadily growing. This is actually a picture from last year, so there are many more at this point. In terms of the data that we make available from the archipelago infrastructure, we have the raw traceroute data. This consists of IPv4 and IPv6 traceroutes. This is approaching 6 terabytes of data at this point, and this is available in its original raw traceroute form if you want it. In addition, we make available curated topology datasets, which we call Internet Topology Data Kits, or ITDKs. We do about 2 of these a year. And this consists of a router-level topology, a router-to-AS assignment dataset, DNS names, geolocation, and other fun stuff. We also provide traceroute-derived IPv4 and IPv6 AS topologies. So there is a lot of this kind of data available, and it's historical. But one of the goals of a currently funded project that we're working on is to make it easier for researchers and people interested in this kind of analysis to actually access this data and do interesting things with it. So we're building support for rich queries on this traceroute data, and the idea is to put them together with other kinds of data such as geolocation, annotated AS level topologies, and router level topologies. So for instance, just to throw some examples out there, if we wanted to look at all the traces from a monitor in Canada, and we have 2 of them at this point, to destinations in Canada, and traces that actually exited Canada, entered the United States for a few hops and came back in, then we would like to be able to support this kind of analysis. Another example, suppose we predicted that a certain region was going to be affected in the sense of a natural disaster like a hurricane or a storm coming up or political instability. We'd like to know all the paths from our current monitors that actually traverse this region. These paths might be rerouted or might even go down when something actually happens. So I could go on with these kind of examples, but this is very much work in progress. So one thing that would be very nice is to hear from the community about what kinds of analysis you would like to do with this kind of data, and then and if it can be done with the data, we'd be very happy to support it. Maybe by the next IETF meeting, we have something to show you. ARC provides an interactive topology on-demand service. So this is called Vela, and it's essentially an interactive interface to all the ARC monitors that we have. So you can, once you get an account on this system, you can log in, configure some basic measurements from the system, which are currently pings and trace routes. You can choose to do these from a single ARC monitor, or you can choose to do them from multiple ARC monitors. And there are various forms of the visualization output. The one I've shown here on the slide is a geomap which shows the trace route, basically geolocates each hop of the trace route and shows it to you on the map. In addition, we've recently built a system for DNS-based geolocation, and this consists of 2 pieces called DROP and DDEC. So DROP is actually an algorithm that automatically picks up DNS geographical hints from DNS names. It uses data that we collect as part of the ITDK, which is RTTs and TTLs towards various interfaces that we've seen. It then uses all of this data to build geographic hints, validate them, and then actually it also tries to extract a general rule for a certain domain in the sense of how interfaces of that domain seem to be named. We have a public-facing component of this system, which is DDEC, and you can access it actually at ddec.kada.org. It allows you to enter a list of DNS names and tries to infer if any geographic hints are present in the DNS names. It tries to return to you a geolocation, basically. The public interface also supports corrections. So if you're operating a network and you have a certain generalizable rule that you can feed into our system, that helps the whole process. asrank.kada.org is a repository of tools and data that have to do with autonomous systems. So we have business relationships between autonomous systems, customer cones, and a ranking of ASs. In addition, we provide for each AS a POP level map, which uses geolocation data to infer where this AS seems to have deployed some infrastructure. We also provide a router level map, basically using our internet topology data kit and putting the routers that we infer for the AS on a geomap. Again, as with the previous case, we support feedback from operators. So we have an interface where operators can go in and enter corrections to the interface, to the inferences that we've made. Finally, very quickly, pointing to some pieces of recent research coming out of CADA. So last year, we had some work trying to infer which networks peer at which IXPs using the route servers. And we've developed a method to infer multilateral peering at IXPs. And this is still work in progress. We're trying to expand the set of internet exchange points from which we can actually infer reliably the set of connected networks. We've recently done some work on mining historical peering DB data. So this is data from the peering DB that we've been collecting historically, and we've mined it to figure out co-location by different networks at IXPs, what kind of peering policies they advertise, how all of this evolves over time. And we can actually find interesting things like geographical expansion of networks just by looking at historical peering DB data. We're currently in the process of investigating connectivity in the LACNIC region. This is very much work in progress, but the idea is to look at sort of connectivity in that region at IXPs and how paths are coming in and out of that region. A couple of years ago, a team at CADA was looking at the analysis of country-level internet blackouts and outages, such as those that happened in the Arab Spring when some countries just basically switched off connectivity to the rest of the internet for their users. And they did this using a variety of data sources like BGP, ARC traceroutes, and also using data from the UCSD network telescope. The same team also did a follow-up study looking at the impact of natural disasters, and such as earthquakes and hurricanes on internet connectivity in different regions, and also trying to develop metrics and tools to automatically detect outages of this type. So all of these publications are online. The data that goes into that went into this research is mostly available to the community, and so are most of the tools and techniques that we have developed. So if a lot of this can be found on our website, and if you'd like to collaborate on anything or just get access to the data, then we'd love to hear from you. Thanks, that's about it. And I should mention at this point that a lot of the work that I presented was by many different people at CADA, and it was spanning several years of work, actually. Thank you.
So thank you all. I appreciate the time that you've taken to prepare this and to tell us about some of the work that you've been doing. I just wanted to start the conversation, and we're going to open the mics in any moment, so if you have pressing things that you want to do, you know how to get to the mic. But I wanted to start by asking a sort of so what question. So we started with some evidence about boomerang routing, and there's this suggestion that we want to keep traffic local and so on. But on the other hand, right, people are paying money for this, and if they really wanted it to be better, if they really wanted the traffic to stay locally and so on, wouldn't they just spend the money on it? So I don't know who wants to hit back, but I don't know. Is it working? Give it a try. Just talk.
Just give it a shout now. Can you hear me?
Yeah.
Okay. I thought it would turn red or green or something, but anyway. In certain countries, they can't afford the infrastructure. Chad, for example, or Côte d'Ivoire, where there is a very strong incumbent, and you often have to go in and try and build that community of interest around a very strong strongly financed entity. So I'm not going to say it's sort of the undercover technical community way of going in, but sometimes you go in and build up that community, then you work with the government to try and figure out how to better interface with them, to encourage them to understand the importance of that IX, to build out that market. It may not often seem so obvious at first, but when we help with some of that startup, if you will, it's important to bring in that equipment. We're not talking about used equipment because some countries are a little twitchy about that. as are the export control authorities. But you do bring in that new equipment, you help them install it, but you're not leaving people by themselves to not understand the technology. You're building up that community and building up their own technical capacity. So that will build up a stronger infrastructure, internet infrastructure in those regions. I would just say there aren't a lot of companies who are going to go in there on their own. That's why we work with the internet technical community and with other, with the RIRs, NSRC, PCH, and others, just who are good at doing this. Many of you in the audience may be. We often look for volunteers if anyone's interested in training and helping as well.
So maybe the IX project, though, has some insight in this. I mean, why does the Canadian traffic all go that way? I think it's pretty obvious that if you're going to go from Toronto to Vancouver, the shortest path is going to be through Chicago. But pretty clearly, the shortest path between two buildings in Toronto is not via New York and Chicago. So what is the financial interest there? I mean, I think I know, but I guess I'm going to ask you anyway. And I guess one of the questions that I really have about this is, given that all of this data that you've collected, is it possible that we can tease out of that those kinds of relationships so that we can see, hey, wait a minute, these things are happening this way, and there's some sort of negative network effect, is essentially a network economic effect that's at work. So I don't know. Antonio, maybe you have some idea about why this is happening.
Well, okay, I think this is one very interesting question that you are asking. From our research, we have been sort of finding these patterns. So what we call the boomerang routing has become more and more interesting for us in terms of questions about privacy, questions about internet sovereignty, and later on, the more we get into this type of questions, we understand that on the one hand, there are reasons why the boomerang routing or the cross-border routing has very specific reasons why it happens. As Andrew just mentioned, there is no capacity to go from Halifax to Vancouver, or there are agreements, or actually there are already networks that are in place that it will be more efficient to go in that direction. However, some of our findings, and that's one of the videos, one of the trace routing that you saw in the video, that we run a trace route test consistently from the University of Toronto to the OSAP, the Ontario Student Assistance Program, and what we discover is that some networks decide to peer with others and not to peer with some and not with others. I know Andrew Clement, my professor, is listening to me right now, so I wonder if he wants to add something here, because this is a very sensitive subject, because it raises questions about not just efficiency, but questions about whether our data crosses some borders, and because of that reason is subjected to other inspections, or potentially is subjected to data inspection. So I guess that's what I would say.
But I think, and I'm sure there are people in the room who will have observed this, that right, the routing isn't going to protect you, because we know that some of that surveillance goes on inside the Canadian border as well. So that isn't, that isn't really protection. So then fundamentally, I guess the question is, does it make the network worse if you have that? And I mean, it seems to me it does, but I guess what I'm wondering is how much worse is it? I mean, what do the numbers show us? If we look at the data you've got, is this really a big tax? Probably in Chad it is, but how bad is it if some packets have to go to New York first in order to get across town? Do we know what that costs? Presumably it's real money.
Well, I'll jump from what we've had this question before, and it was very interesting with some representative from Torix, which is one of the main internet exchange points in Canada. And as far as I understand, and as far as we understand, there are deals between big internet, big ISPs and small ISPs. So the question about whether it's more expensive, I presume it has to do with who owns the network and what kind of deals are taking place in those exchange points, and to what extent the people or the partners that you decide to peer with are mediated by the economic or financial reasons as well. So the idea of the cost, I think, is related with the peering, the type of agreements that are taking place there, and of course in terms of relaying, how long it has to go. Maybe some other, with more the technical, you were mentioning before, like how increasing or decreasing the latency is actually some things that we have to do and we are aiming for. But we know less of that, and we are sort of learning that this is something that has to be looked at carefully.
So one thing I'd just add to that is perhaps the role of longitudinal measurements in trying to tease apart some of these issues. I mean, there is data that exists about business relationships and characterizing whether two networks are customer providers or peers, and these things change over time, and we can track these things historically and perhaps correlate them with performance data in the form of the sort of longitudinal traceroute data that we have, and try to tease apart the issues that, like, okay, this peering changed at this point, and how did it affect latency going from a monitor to certain destinations. And this might shed some light on the question of what you were getting at with respect to how much these things actually cost in terms of how much better could it be. Right?
Do you think that the data set that CADA has is at least a piece of that, or do you think there's data sitting there that people could tease that out of?
I do think so, yes. I mean, there is a lot of traceroute data, like I said, and we also have the AS relationships and AS level topology data historically. So perhaps putting these two together can give some answers.
I see someone at the mic.
Hi, Jacques Latour. I'm with CIRA. So we're on one of the sponsors for IXmaps. And at CIRA, we're .ca, so we've been doing some research in Canada for IXP. In the last, 3 years, we had 2 IXP in Canada, and now we have close to 7. And so one of the big changes that we've seen with putting a new IXP like in Winnipeg is first of all, you have to build a community to get the IXP together. And what changed there is the cost for bandwidth went way down. So the fundamental problem is the incumbent in Canada. They don't want to peer with local ISPs because they want to bring the traffic in the state and make money there. So right now we're building what we call a donut architecture in Canada around the incumbents. And the challenge is getting them to peer in Canada with IXP. And I think it's legacy. They think that if they peer, they're going to lose revenue. And that's pretty much where we're at. So the big thing that's happening now because of all the new IXPs is tier 1 carriers are moving in Canada and not competing with them directly on their soil. So now that we've got new IXPs, the landscape's changing, and I'm not sure where all of that's going to go. But price is going down right now for bandwidth, so it's all good.
So, Jacques, before you go, I alluded at the beginning of my opening remarks that Canada's a big place. And there's not very many people in it, and there's a lot of sparsely populated areas, of course, that presumably are not getting these IXs, or is that one of the targets of your program? Are you explicitly going after places that are perhaps underserved because there's nobody there?
The idea is to go coast to coast. The core of the internet, the top of the internet is the IXP. That's where you generate bandwidth. That's where content providers go. This is where people can get high volume of data for low cost. So Halifax is now up and running, HFX IX. They got 10 peers. New Brunswick, we're working. So pretty much every province, all the way to Vancouver, we have new IXPs running. The key thing is that we need to work with them to build a community so they can be sustained and operational on their own. We can't run it for them. We can't help them. So it's growing. Even Kingston is looking at building an IXP. So,
thanks. Is this a mic line or no? They're just having a side conversation. Good. So, Jane, that sounds like something that's fairly similar to your experience in some ways, but of course you're dealing in areas where you've got lots of population, but you've got, you know, maybe other incentives that aren't working. So, you were mentioning that there is some concern about you know, people moving in because they you know, come in with the IXP and you know, maybe it becomes a point of surveillance or whatever. But this sounds to me like, you know, a sort of false problem, right? Because the monitoring is already happening. So then the question is, can we measure out of these things the positive benefits in those localities? Some of the numbers you were showing were pretty great, and what's interesting, of course, what Jacques just said, it's going down here too. Is this a widely spread data set? Is it shareable? Can people you know, find that stuff? Because maybe that will encourage this development.
The data sets that we do have for Nigeria and Kenya are in the report that the link is in the presentation. We also have data that was newly collected through the researcher in Argentina in the Latin American Caribbean report. We're working very hard to try and collect more data. It's not easy if the IXs don't have the software installed already, and that's something we're trying to do in different parts of Africa with existing IXPs that have been developed. Put those servers in, work with them to understand that it's not surveillance software, because that's a question that is often asked, and encourage them to also put up the statistics for their daily, monthly, or daily, weekly, monthly traffic and annual traffic. If companies don't see that there are eyeballs on the network, it's difficult to think about why you would go and invest for some companies. Others get it. They're already doing work in those regions, like Lyon IX from France is actually working very closely with French-speaking West Africa to help us do some of the training, Jaguar Networks, because they see this is the next community of interest that is being developed, and those infrastructures will grow eventually. But as Jacques said, it's very difficult to grow those communities of interest just off the bat. They're not mushrooms. You just don't sprinkle some water and they come up. It takes a lot of time and energy, 2 to 3 years. In Trinidad, it was 7. They just launched, I think, last month. I know from my colleague Christian, it's 2 to 3 years right now in Bolivia, and it'll take some more time because you're growing that community of interest, and you want it to be sustainable, so it's not something that you just impose. It's like what many of you did so many years ago. Just think about where you started. People are starting over in many places, so it's important to bring that along slowly and not to try and force anything so it doesn't look like we're trying to do something that would have surveillance implications. There are governments who are worried about this, and that's where we do get those questions, a lot of training workshops. Again, a lot of those governments aren't monitoring the networks per se because there's so little there to monitor, but they're probably thinking of doing that. It's just a fact. So the question is, what do we do to encourage a proper technical infrastructure that's devoid of that sort of, devoid of that issue, or try.
Is this mic on?
There you go.
Hi, my name is Tim Shepard, and the first speaker, Antonio, is that your name?
Antonio.
Yes.
Yes, just a fairly simple question. You were showing the path between the two routers that showed up in your trace route as a straight line or great circle on your animation, but it's actually something else. And I'm wondering how, have you all looked into actually finding some way outside of, I mean, traceroute won't show you this, but finding some way to find out what actual geographic path is being used between the routers that show up in your trace route. And I mean, the obvious question is just because two routers that showed up in your trace route are both in the same country doesn't necessarily mean that the path between them was the shortest path and didn't go all the way around the world or something through many countries to get between the two routers. So have you looked into that at all?
Well, thank you for this question, because it's been, I remember the first time we started with Google Earth and starting being this, looking at these very nice and smooth lines that become sort of misleading sometimes, because as you pointed, we have very tremendous challenges in terms of geolocation and geoprecision. Some of the things that are, this question has come in terms of where is it at the building level? Is it the router at your house? So we do have some questions or issues about geoprecision. Some of the databases that we start with are MaxMind. Some of you might be familiar. We rely on crowdsource, people telling us, you know, I know that router is there because it's my house. Or some building levels like UFT, we run from that. But despite the precision of our geolocation, the aim of our project has been, our geo-precision has been sufficient for the goals or the aim of our project, which is, at this point, the city level will be enough for us to say that packages are going from Toronto via New York and then to Montreal. So we don't have a solution for that. I know that Andrew and other of my colleagues calling over there, he's working in that particular aspect of geolocation. But as I said, we're welcome for comments or suggestions on how we can do that better. Thanks.
Rüdiger Volk, Deutsche Telekom. For Antonio and the kind of research, in particular for the more developed parts of the internet, I wonder how much you're actually presenting the full picture. Is it important to know whether a certain router is in this block on the Toronto map or on the other side of the town? Not quite sure. In Germany, I would know certain things that are closer to certain installations, which might be something interesting, but actually, does the IP routing trace really show how the traffic flows? How much traffic is actually directed by users who sign up with an email service somewhere across the globe? And, well, okay, is that stuff that is actually pretty much under user control? They don't care, unfortunately. How much traffic that is routed in interesting ways is to be observed at the IP routing layer, and how much is actually happening more on the application side?
So I'm not sure I have a great answer to that, but we do trace routes. We don't really know how much traffic is flowing on those paths, but perhaps one way to look at those kind of questions is to do trace routes to the kind of content you care about. So you try to identify the CDN locations where traffic is coming to you from, and look at the paths from you to those CDN locations, and if you've managed to get the locations of the top content, then maybe you have a better answer to the kind of question that you were asked.
Another idea to help with that, and this is just a suggestion, is that when you live in certain developing countries, you don't have an option for a very consistent service that you have a lot of confidence in. I know this from having lived in certain places, and you use those external services. When you do try and build a local environment and you host more services locally, you could take a look, say, for instance, through what the project we're doing in Bolivia, take a look at the snapshot of the market now, where the traffic is being routed, or where we know the traffic is flowing, the different traffic levels out of the country, across the borders. And then after the IX is installed, to take a look at what those traffic level differences are, the quality of service levels, or latency, and do some other corollary activity. But we could actually take a snapshot there. And I know some of the research that EuroIX and others are doing, they're trying to take a look at that as well. So that may be something where we start to take a look in those emerging markets to try and take a stronger perspective and do more analytics by taking putting in the servers, looking at the measurements, working with the community pre-IX, when the IX is installed and after, so that we can help with that data correlation.
Well, I would like to add just a quick note on the question about how much traffic goes on the application level or the user level. For us, it's a very interesting question because currently our trace route generation application is, as we mentioned before, it's a crowdsourced application, so it's run on a specific ports and it's run on demand by the user. In the next level of our trace generation, we are thinking on more like a background application that could be monitoring the tremendous amount of the services like happening when you are going to services like Gmail, Amazon. So there is tons of exchange that is happening on the background of your computer. So in terms of, and having said that, part of the aim of our project is to raise awareness about that privacy, that potential vulnerability of your privacy that is going on behind the scenes. Yeah.
So I'm conscious of the time, so, and because we have the IAB tomato throwing event up next, I thought that I'm going to cut the lines now, and I'm going to start here, and I'm going to move around. So you're first.
Thank you. Carlos Martinez Lagnic. This is question/comment for Antonio. I really appreciate your work. I think it's very interesting, very relevant. I do have an uneasy feeling about the use of the term efficiency, because efficiency is something that is tied to a metric or indicator. You optimize things to be efficient in terms of delay, cost, hidden costs in terms of red tape, for example. So someone could argue with you that the current path the traffic takes to get from BC to Toronto is perhaps the most efficient one in terms of regulatory landscape, cost of laying fiber, things like that. Things like go beyond strict efficiency in terms of delay or distance. So I think my point here is that the perceived inefficiencies in how traffic is routed have underlying causes that go beyond technology. And those underlying causes should be addressed as well. Because if you change that I mean, I would say boundary conditions, you can get the system to fix itself in a way. Thanks.
Joel Yegley. Yeah, so I think my observation sort of dovetails with that, which is that there are geopolitical and economic considerations here that created these pathways, and they're pathways that are used for things other than internet transit, for example. And so the implications of those sort of have long-lasting consequences. I mean, if we ask why it is that the path from Chicago to Vancouver is about 900 route miles shorter, give or take, than the one from Toronto to Vancouver via Edmonton, you know, we don't really have to wonder about that, but we can blame the Ashburton Treaty for it, which there are a number of Canadians who blame that for all sorts of things, right? Because the British sold you out. But sorry, yeah, I mean, there's some simple physics there that people who like rapid phone calls and computer games that run fast are really in favor of, that are actually sort of hard to defeat without redrawing lines or not worrying about them as much. So I don't really have to think very hard when I wonder why traffic goes to Chicago or New York from places that have very dense economic ties with those locations, right? Trucks do, so do ships, and people in cars and airplanes and so forth. So it's not just the packets.
Jane, one of the more interesting metrics I thought you presented was the cost per unit bandwidth. And I'm just wondering, has any effort been done to sort of map this to geographies and to use that as a way to sort of focus attention on particular problem areas?
My colleague Michael Kendi, who's an economist for the Internet Society, has done some mapping and some corollary work. We're going to be working more together to do some of that, as you're suggesting. We've got some mapping together now of the IXs, but we also want to take a look at the corollary cost considerations where costs have come down, where latency has come down, and look at, analyze it in greater detail to look at some of the other factors per region and per continent, and what we can divine from that. Because obviously some of this is regulatory and policy, some of this has to do with a strong technical community. And look at those different factors. It can help influence how you go into a certain region, how you work with a certain community, and try and, you know, push-pull on different factors. We could be more efficient, actually, if we did some of that, and I think that's definitely in the near future. It's just putting all of that together with an economist, with the technical experts, and getting some of that data. It is hard to get the data, I'll be honest, and that's part of the objective of what we're doing in the toolkit, but also all the colleagues around the world are trying to do the same. I will say the RIPE Atlas project has some great data, so if we can start to think of ways to correlate some of what Amog may be doing, and you, Antonio, and the others, to bring some of those data sets together, we could find some better answers to that question and try and be more efficient with what we're doing and how we do it. I will say one thing about speed. I'm reading a book called Flash Boys that was recommended to me by Phil Roberts, who I know is in the room. If you think about what some of the, and this is in the highly developed markets, right, where they're trying to bring down the speeds by, I said, oh, seconds. He said, no, Gene, we're looking at milliseconds here. And I said, right, right. But if you think about the new network topologies where they're trying to put in a straight line between Chicago and New York in order to trade faster, that's a whole different issue than what we're trying to do in Kinshasa. Where, quite frankly, after the IX was up and running, the mobile operators found in 4 hours that the quality of service had gone up for their network delivery, for the traffic delivery. So you've got humongous different aspects here of, with the developing countries and more developed, but we can learn something from each of those experiences for sure.
It does strike me, just picking up on what Joel said before, that it would be interesting to take some of the data that you've got now, for instance, the CADA data, the IXmaps data, look at that and then track the new IXs going in and say, well, is that actually changing the way these patterns are? Because that, I mean, Joel's point that, well, people are following the patterns that they ever did. If there's a new road there, do people change direction? Because they don't always, right? I mean, just in physical space. Anyway.
So the first one is a kind of a comment and a question following that. I was wondering how much of this strange routing is due to the desire to aggregate to the points where the carriers have so-called free arrangement of exchanging equal amount of traffic on both directions. Maybe those are the points they want to go, and they want to aggregate enough traffic so that they can utilize that whole thing. And kind of my question kind of dovetails that if you have two carriers who don't have equal amount of traffic, let's say, you know, probably right now everybody knows that, so Netflix uses level 3 as one of their provider, and that peers with Verizon, and then of course, you know, Netflix is pushing an enormous amount of data compared to what will go upstream from Verizon back to level 3. So do you have this kind of problem where you don't see the carriers don't want to peer because they would not get a favorable economic arrangement?
Yeah, so I'm not sure we catch all your question, but you're mentioning, could you rephrase quickly your question, very short?
Well, basically saying some of the peering points have economic advantage because let's say carrier A is talking to carrier B at point P, which could be in Chicago, for example, but they have arrangement that they can freely exchange data. So they will try to move all the data through that, regardless of the actual distance between the two final destinations, right? And if you cannot create such a partnership with two carriers, will they even be encouraged, or will they be even willing to create a peering relation among themselves when you're trying to encourage more IXPs?
I will just say that some of the more advanced networks, perhaps run by an incumbent, don't necessarily peer at an internet exchange point. In Johannesburg, which is a 16-year-old IXP, the incumbent isn't peering at the IX, so there are some smaller networks which may not be as sophisticated, but they become more, they level up, if you will, from a technical perspective. as there's more confidence in their own infrastructures and making more money and they're exchanging traffic, it's, you know, it's just a network effect from that peering at the IX. Incumbents aren't necessarily necessary, and if I guess the point you're making is that you have to have two really great networks in order to send your traffic, well, that may be true if we're running stock market traffic, but if you're talking about just getting better quality of service, lower latency, more efficiency from the network engineers who are learning how to better route traffic, quite frankly, some aren't deploying BGP and they need to understand how to do some of that engineering, and we try and help there. But those network efficiencies do come about after some time, and that's where some of what may be considered the less sophisticated networks grow and become better at what they're doing.
So I did close the line, but there is, if you can make it short, you can go.
I can, yeah. Robert Kirchstecker, IPCC. You said, wouldn't it be nice to start collecting data before, during, and after the IXP deployment? We are exactly doing that together with ISOC. So we started that thinking process at the minimum. We have deployment. We also have deployment in Africa, which is difficult to do. Yeah. But we could and did start local measurements, you know, whether traffic is within the country or not. And we would like to help ISOC figuring it out. Where are the best spots for IXPs and how does the things change if you actually have an IXP locally. So we are on that together with ISOC.
Excellent, thank you. All right, I want to thank Antonio, Jane, and Emil. Thank you very much for your time today. And with that, I believe we're bringing the rest of the IAB up. Yes. Thank you very much.
Okay, so Andrew's over there. He's the one that asked for the tomatoes. We'll start down here with Mary for the introductions.
Mary Barnes, IAB. Sorry, Mary Barnes, IAB.
Yari IATF Chair. Ted Hardy, IAB.
Lars Eggert, IRTF Chair.
Cindy, IAB.
Elliot Lear, IAB.
Dave Taylor, IAB.
Russ Housley, IAB.
Eric Nordmark, IAB.
Joe Hildebrand.
Mark Blanchet, IAB.
Joel Halpern, IAB.
Brian Trammell, IAB.
Andrew Sullivan, you already know me.
Heather Flanagan, not IAB.
Okay, the mics are open.
Okay, we're done.
Going once. Going twice. Marsha's running to the mic. Okay. Enjoy your dinner.